Hello, hello. Okay. Okay, cool. Yeah, so welcome to Coffee with Ryan, episode number 2. Unfortunately, my coffee is empty. I think I'm 2 coffees in today. So we will do it without. We'll push on. Thanks for joining me today. This is a interesting episode because we are going to be looking at the serverless Twitter. Obviously, we did that last time. If you saw serverless or Coffee with Ryan, episode number 1. But today we're going to be doing the same thing, and we'll be kicking it off today with Jeremy Daly's post here about a exciting thing that Serverless Inc. is coming out with. Serverless Guru is a partner with the Serverless Inc. And the idea of this serverless cloud seems very interesting, and so we'll see how that develops, and probably more on that in the future. So Jeremy Daly here saying that if you're interested in becoming a serverless cloud beta tester, they're opening up submission for you to get early access. And what that looks like is you can fill out this form here. It looks like a Google Doc, so let's just open it up, see what it looks like. So you can see here, serverless cloud beta tester, you put your email in, what type of frameworks you're using. It's got all the normal ones here. Framework technologies you're using to build applications on the cloud, so a whole bunch of different ones here. Developer cloud engineers on your team, following describes your role, primary cloud application use case, and then if you would be available for a 30-minute call. And if you do those things, potentially Serverless Inc. will reach out to you to get beta access to their serverless cloud. And then if we click into this, I was reading this a second ago, just very briefly. It says, is SLS cloud hosting infrastructure provided by serverless, or is this the cloud deploy? I recall Austin prototyping, Austin's the CEO, Austin Collins is the CEO of Serverless Inc., prototyping that still deploys your own AWS or other account. Jeremy Daly got back and said, with Serverless Cloud, Go Serverless is completely managing the infrastructure for you. No need for setting up your own cloud provider account. And so this is interesting because this is a kind of a really important topic. So what does this look like in practice? No need for setting up your own cloud provider account. So to me, that means that serverless cloud made by Serverless Inc. will create your AWS account or other cloud provider account under the hood, which means that there's probably going to be really tight integrations between AWS, GCP, Azure, and other cloud providers to this serverless cloud. And you won't have to potentially switch into the AWS console, and you'll be able to do everything from the serverless cloud that you normally would through the AWS console or through the GCP console and so on. I don't know what cloud providers they'll support initially, if it's based on any of the other types of serverless offerings that have come out. Usually AWS is the first one, and then from there, maybe Azure support or GCP support, but usually it starts off with AWS, so we'll see what they do with this. And then Daniel got back and said, thanks, I suspected the same. That might be the case. Big move for serverless. And then Jeremy Daly said, there are also huge investments being made into the traditional serverless framework and lots of really cool things to be added there as well. Serverless Guru is, huge, power user of serverless framework. Personally, I think I've written some stack of articles and tutorials about serverless framework and how to build applications, full stack applications with it, and even made a course on it at training.serverlessguru.com. And you can see the 0 to paid professional course. It's like $25, and what it does is it basically walks you through how to build serverless applications. Specifically, it focuses on like a beginner mindset and how you might tackle AWS manually through the console first, and then slowly working your way up through infrastructure as code until you get to the point where you're actually using serverless framework. And right now it's a CRUD application, CRUD API, and has like a Lambda function or a couple Lambda functions mixed in there with serverless framework and a deep dive into that. It's about 94 lessons at the moment. We plan on expanding it out to observability, CI/CD pipelines, and a whole bunch of other good stuff, including a front end, cognito authentication, all that stuff as well. So if you're interested in serverless framework, give that a look. Or if you haven't heard of serverless framework, but you've heard of AWS SAM, CloudFormation, Terraform, they're all sort of similar, CDK, and highly recommend the serverless framework for building serverless applications. So that's that. Looks like we got a refresh in our feed. We've got, let's see, Kilo Loco here. He said, I've officially become a serverless developer. I created a Lambda function that accidentally triggers itself and ended up with a $25 bill. Good thing I got the warning when I did, so the charges didn't continue. Yeah, that's, I think we've made the, I've definitely done an infinite loop, or set some cron timer or cron tab and forgot about it through like a CloudWatch trigger. So yeah, welcome to the club. Let's see, microblogging with serverless Redis. So this is interesting. So this is from Fullstack Frontend. Having a serverless version with Upstash makes it even better. So looks like we got a link here, and so let's click into it. All right, so we are over here on dev.to, and we are looking at Fullstack Frontend. The author is K. So it looks like what they're using here is something called Upstash. So I'm not really sure. So it said last week I found out about Upstash, a managed database service with a Redis compatible API. It also comes with on-demand pricing. So that's interesting. So it's a managed database service that is API compatible with Redis, key value store, and comes with a serverless pricing model starting with a free tier of small databases. Upstash, like DynamoDB, is a NoSQL database, but Upstash goes more in the direction of simplicity, which requires you to put more of the data modeling into your application code. And it also comes with a GraphQL API because that's a thing. Yeah, that's definitely a thing now. When they get on par with Redis features like PubSub, this will map very nicely to GraphQL subscriptions. Okay. So microblogging with Redis, plan to build a company internal microblogging service. I'm just gonna kind of scroll through here, and if I see something, I'll comment on it. Okay, so data modeling with Redis. Upstash doesn't support all of the Redis features yet, so I would have to get by with just the basics. So try it out with hashtags, a string that contains text, which in turn is sprinkled with hashtags. So that's more there of how to set these up. Post : ID, posts. Connecting with Upstash. They have a Redis endpoint. So they have environment variables here, which look like they're inside of a upstash-microblogging stack.ts file for TypeScript. And you put these inside of your environment variable here, or inside of your environment TypeScript file. Database endpoint, database port, database password. Looks like we're using EUS1. This looks like the Upstash UI here. And then we have the actual database connection code, which is inside lib backend index.js. And Kay also lists the project on GitHub here, which probably has this information. And it said that he used CDK to create an API gateway backed by a Lambda function that connects to Upstash. So he's using CDK as the infrastructure as code provider, comparable to something like AWS SAM or serverless framework. CDK doesn't work the same as, I guess it does. It compiles to CloudFormation as well, I believe. So yeah. Yes. So it does work the same as something like AWS SAM, but the syntax, I believe you write like JavaScript or Golang or Python or something like that versus writing, the AWS SAM syntax, which is very similar to CloudFormation, or a small abstraction over CloudFormation with something like serverless framework that does a lot of resource generation under the hood. And then he's creating an API gateway backed by a Lambda function. Okay. So let's keep scrolling. So this looks like the code that actually creates the connection, and this is important. It's outside of the function body, so it's only created on a cold start. And why he pointed that out there is that he says here, all subsequent requests handled by that Lambda function are handled with the same connection. Because if you put it inside of the actual handler code, each time that a Lambda function runs, it's going to keep triggering additional connections to the database. this a bit closer, just in case you can't hear me. All right. And continuing to go down the list here, we've got the CRUD with Upstash. So you can see the create code here. So it looks like he's got a function create post. Looks like he is Redis client.increments post ID, gets an ID back, post key, uses that to then, looks like he's grabbing something or setting it. My Redis knowledge is not great, full transparency, but I will try. And then moving on down, we have the extract hashtags function. Looks like he's doing some regex matching code. Then we have the read code here. So hashtag gets passed in. We set up the Redis, what I'm assuming is a key string. And we have a ternary, I believe this is a ternary function in JavaScript, which is, if there is a hashtag that's passed through in list post, then use that to create the key dynamically. Otherwise, just put posts, which should pull back all the posts. So it's a way for K to simplify his JavaScript so that he's not writing a separate function specifically just for pulling list all posts and then list post by ID. So he's kind of skipping that by just having this one line in this ternary function here. And then he says await Redis clients and s members, which I'm not sure what that is. And then set key. So, okay, so set key, potentially the key, right? Like hashtag, let's say, gas shortage is one that's going on currently in the US. So gas shortage, and then gets back a whole bunch of post keys. So assumingly, maybe this is all the posts or whatever that used that hashtag. And then he gets that back as posts. So maybe that has the actual content inside of it. And then he's using a map, which is a functional programming way of looping over data to then pass in text, which is a temporary variable, and then I, which is the index value of the loop. And then he's saying ID. So he's creating a new objects here, ID, and then post keys, and then I for index. So each loop should pull a different post key in. Set that as the ID. I believe this will get back the value. So maybe the post keys and then the index value here, and at least in this example, pulls back some unique ID and then text. So that's the actual value of what's being looped over. So I believe that's what's happening. Feel free to correct me in the comments if that is not correct. And let me actually check to see if there are any comments, just so I'm following everything. No, it looks good. Okay, all right, let's keep going. So continuing down this path, we get to the bottom here and we can see conclusion. Upstash is a fresh take on managed Redis deployments with a free tier and on-demand pricing. Pretty cheap to start with. Since it's just a key value store, it requires you to do more data modeling in your own code. And for this, I should read more about Redis in general before considering it in my product. Probably end up writing something, the whole thing in data layers. Okay, my brain just split in half right there. But since the latency is so very low, it should make sense to use Upstash as a primitive for building a data model. Okay. All right, still missing some features here. And if you need a full text search or geospatial queries, you have to wait, but overall seems like a solid offering. It would also be cool to integrate with infrastructure as code tools like CDK or Pulumi. But I think this isn't a big problem because they already offer an API to manage databases. So yes, I think my initial thoughts on this is where, I don't know if it was stated, but why using this, right? So still in a search for a data store for my microblogging SaaS product. Read the DynamoDB book. Okay, so assuming that's by Alex DeBry's book. Had the impression that the database isn't quite optimal. Okay. And then last week found out about Upstash. Okay, so potentially is it the right solution? Maybe in some cases, maybe not in other cases based on context. I think, my first reaction would be to use something like the DynamoDB API. Yeah, but that takes a whole different skill set potentially versus something like Redis where people are very used to using that. I think we also, a lot of times my default is to stay underneath the AWS umbrella, and I'll do that just because it's a bit easier long term because as more features are released by AWS, the less amount of third-party platforms that I'm relying on for these applications, the kind of easier it gets. So let me actually refresh this real quick, and let's keep going down the list. Okay. All right, so we've got Emily here that said, thought I'd play around with servers, so I'm trying out writing a Flask app in Python. It's already been really interesting to notice how much thought process is shaped by serverless. Okay, let's see. All right, so we're over here on the digitalocean.com website, and we're scrolling through it. So it looks like Daly. I hope that I said that right. I probably didn't. Please forgive me. Introduction, Flask. So Python framework for building web applications in Python easier. So let me just kind of move through this. So we're installing Flask here. Pip install Flask. Python-C. Creating a base application. So we're using Nano to open a file locally in our terminal, adding in our Flask code. So we have an app.route here of /, and then we have a Python function which when it runs, it's going to print back hello world. And we're using this kind of syntax here to say like app.route. And so we could have something like app.route / account and then have an account function, I believe, and then return things back from that. We have some variables, some environment variables that we're throwing out. So like Flask app and also Flask environment of development. And then we're running Flask run, which runs a local server. So not quite serverless, it seems, right? We are kind of running a server locally, but let's keep reading and see how this goes. So we're serving Flask, so it's got lazy loading, environments development, debug mode on. We're using the 127.0.0.1. Scrolling down even more. Using HTML templates. We've got an app.py here. Again, rendering template when the app.route gets loaded. And it's going to load the index.html file that we've created. And then we have a template / index.html, which we put in here for welcome to Flask blog. And then we create a CSS file, which has an H1 CSS definition. And then it looks like they create, I guess it's just linking to it. So there's a style sheet reference here, and it is referencing the CSS style.css that we just created, which had the H1 information in it. And then we reopen, we either reopen or create, I think we're creating a file called base.html now. We had index.html, but now we have base.html. And then I believe they said Jinja templates, so I think that's where this curly brace syntax comes in with the percent signs. So we can say block title and end block, and I believe this can be done dynamically, potentially driven by our Python file. I believe that's the case, but let's keep reading. Okay, so a block that serves as a placeholder for a title, and this URL for index is a function that will return the URL for the index view function. And this is different from the past URL for call that used to link static CSS file. So we've got this function here, href URL for, and then index. And then I believe there was one up here, URL for static file name, and then the style.css. And I believe this is for organization, so it's kind of pulling these things together. And then we have something here, which is template / index.html. Inside of here, we can see extends base.html, block content, h1 block title, welcome to Flask blog, end block. Okay, so let's see what that turns into. Welcome to Flask blog. So that makes sense. The block title here has Flask blog. And then we have the about word as well. So let's scroll back up. I actually want to see where that came from. Okay, so here's the about section. And then we have the Flask blog section, which makes sense. And then we have the href for if they click the Flask blog, it's going to use this URL for index. Okay. All right, and then we're using SQLite database. So hopefully this isn't too boring for people that are watching. If you're not used to Python or learning how Flask applications are built, then maybe it's kind of interesting. If you are familiar with that, then maybe this is not so interesting, but I'm going to keep going anyways. Schema.sql, so we can set up our schema.sql file here. So this is typically, we'll keep SQL schema files like this because it makes it easier in the future for us to recreate our database structure if we're using relational databases. And so you can see here they're using SQL, which is drop table if exists post, and then create a table post, and then they're adding in the various fields here. So text fields, timestamp fields, and then of course you have the ID here, which is an integer and uses auto increment. And then we have the created timestamp, which is the current timestamp. So this is pretty standard. And then if you want to add additional fields here, you can just copy paste this, add a comma, and put name, put address, and put other things in there like that. Scrolling down more, we have the initdb.py file. So I just realized how large this thing is, so we might actually scroll down to the bottom and kind of wrap up early maybe. But we can create a connection here in this Python file. And if you haven't seen Python, if you're coming from JavaScript background, you can probably read this pretty easily, right? So it's not super foreign. Python's great. I mean, you can see how small amount of code this is. Connection, cursor, and then we can use the connection to execute SQL statements. So here we're inserting into the post table, which we just created with .sql schema, and we're passing values of the question marks, which I believe allows us to pass in dynamic data. And our dynamic data is our second argument here in the execute command, which is first post, which is a string, and then also content for the first post, which is another string. And then you can see here we're inserting another post, which is second post, and then finally we're committing, and then we're closing the connection. And we move down here to displaying all the posts. So we have an app.py file here. And so we're going to create a DB connection here with SQLite.connect. And then we're going to return the connection from this function so we can use it later. Then moving on down, we still have that app.py where we set up that initial app route. And we're saying connection. We get the connection here, so we have that as a variable. And then we're saying connection.execute, and we're selecting the posts from the post table, and we're saying fetch all. And then we're closing the connection. So now we have this variable here that holds posts, all the posts inside of our database, which is just the first post and second post. And then we're going to return our render template, which is our index.html with post equals post. And now I'm assuming that's where the Jinja templates come in, where it takes that dynamic curly brace and percentage sign, which we saw earlier, and swaps it out for the real data. And then moving down, we kind of see that here. So we have block content, title. So now you can see where does the content, this content variable is coming from our database file here. So yeah, so you can see that there, content and title. So anytime that we see block and then content or block and then title, we know that that's coming from our database code, and it's going to loop over it. So to kind of show how that works here, we have the block content here. So that would show as, I think, our first post content. And then we have block title in this H1, which would say first post. And then we have this syntax here, which is for actually looping over these posts. So we can say the curly brace percentage sign, which is how we start all these for post and posts. So that would be all the posts that came back from our database. We have this post variable, and then we can call it using the bracket notation. So we can say post bracket title, which is the name of the actual field in the database or the column, and then that will come back as the actual value. And then we could say post bracket created, and that will come back as the timestamp value from our database. And what will happen is it'll loop over creating two of these because we only have two data inside of our database, and then it will stop with the N4. And you can see that here. So we have the welcome to Flask blog, first post, timestamp, second post, timestamp. And then moving on down further, since we're already on this path, this warpath, to get through this huge, long DigitalOcean thing that has nothing to do with serverless, we have the app.py here, and it looks like we're importing some exception handling potentially. So we're saying here, pull that stuff back where ID is equal to question mark, and then remember the second argument is the post ID, and then we say fetch 1, And then we say if the post is none, which would be when it actually makes that request to the database. If it comes back empty, then it's going to abort with a 404. And the abort functionality comes from the import that we just made from the workzug.exceptions library, which we imported up here in our app.py. All right. And then now we have another route here, which is our slash, and it appears to be some type of syntax here, which I haven't seen, which is the int post ID. I'm not sure if this is, I guess this would be a dynamic way of saying if it comes through as an integer and post ID underscore ID, then pass that through as post ID. So potentially this is how we reference it here. I'm not quite sure, but we get the post back, and then we're rendering the template with the post.html. I don't believe post.html has been created yet, which implies that we're going to have a separate page, which is now being passed a single piece of data, and then we're going to use Jinja templates to then show that on the screen. So we can see that here. We have content coming through, we have title, we have the post bracket title syntax, and post bracket created syntax, and post bracket content syntax. Finally, we save it, and now you can see here that we can go to, localhost :5000/1/2 and /3, and each one of these should reference the post.html file. And so let's show that here. So we have a hyperref here, and so we're looping over the post, and then we say URL for post, and then we have post ID, post, and then the ID here with the bracket syntax. And so what that'll do is that now our index.html is going to loop over the data in the database, all the posts, and then it's going to create an individual block for each post that's clickable. And then when you click it, it's then going to open the post.html where we actually have the individual data about it. And so now you can kind of see how all this is working together. And so I am going to scroll a bit through this now that we have a basic idea of how this is working. So let's keep scrolling. Okay, so we got towards the bottom, so now I'll scroll up just a little bit so we can close out. But yeah, so once you go to it, you can actually see the content there. Well, you can see what they ended up doing is they created a way for you to actually create additional posts into the database. And you can assume there that when you hit the submit button, there's a function behind it that grabs the connection, sends the data with the SQL query the same way that we were pulling data in using the title and the content input there, and then storing that in the database. And yeah, so. And you can see here we also cover the delete here, or DigitalOcean does. I'm just a spectator. Okay, if you've never worked with Flask or Python before, or Jinja for that matter, or SQLite, this is a pretty good tutorial. It's not exactly serverless, but it definitely is useful. And even me, it was a good refresher. I haven't worked with Python since I worked at Nike. So this has been a little bit, and yeah, and that's actually really easy syntax to do this this kind of like mapping and stuff. So if you're already working with Python and Flask and all that, or you're interested in it, hopefully that was a good overview of it. So thanks for sharing, Emily. All right, I think I've got energy for one more. So, well, quick shout out to my post here. If you love building cloud applications on AWS with a focus on serverless, keep Serverless Guru in mind. There we go. So I'll open this up because that is what I would do in this situation. And you see here, senior serverless developer, 2+ years of experience. If you have 0 to 2 years of experience, reach out as well. If you like building apps on AWS and you're interested in serverless, reach out to us. Like if you have a background in front end or back end or project management, whatever you think would be useful to Serverless Guru and the stuff that we're trying to accomplish here, definitely reach out, because there's always a chance that we're actually looking for it and we just don't have that specific job post up. And you can see here some of the stuff that we're doing on a daily basis with clients. This is just a small taste of it, and how the hiring process usually goes at Serverless Guru, just for full run through, is we'll get candidates that submit this form with the resume and LinkedIn. And then we'll share that internally to team leads at Serverless Guru. They'll evaluate it, and then we'll respond back with some times for initial meetings, things like that. And then following that, we'll do a code challenge. And the code challenge will be something like building a CRUD API, showing your experience with infrastructure as code, like serverless framework, for instance. And then following that, we'll then evaluate with team leads again. And if we feel like it's a good fit, then we'll move forward with all the contractual details and all that stuff. It's a pretty low friction way of doing hiring, but we really try to focus on seeing like the evidence of actually being able to build something. And I think that that's the most fair way of handling hiring as well. And we're remote. We're based out of 10 different countries. So if you go to our company page here and you look at our About section and you scroll down, you can see that we are spanning 10 different countries all around the world. So that's kind of exciting. We've got a really cool culture starting to be built up here in Europe, also in South America, and over in Southeast Asia. And then, of course, we've got some people in the US as well. And we've got one person out here in the middle of the ocean. So that's kind of exciting. All right, and then next up we have Vadym. Hopefully I'm saying that right. I'm saying it very confidently as if I am. So when to use Docker on AWS Lambda, Lambda layers, and Lambda extensions. So this seems like a deep dive, and so let's dive deep, all right? We've coming over here to Medium at blog.devgenius.io, and we can see Taavi here from Dashbird wrote an article, when to use Docker on AWS Lambda, Lambda layers, and Lambda extensions. So we've got Docker plus Lambda equals brain. And the original was published on dashbird.io. So, okay, so let's scroll through here. Some new updates are out the door. 2 of them are Lambda extensions and support for Docker images. And we're currently using custom Docker runtime images for running, I believe, .NET on AWS Lambda for a client, and it's going pretty well. And we used AWS Lambda extensions previously to get what I believe, oh my gosh, what is it? It was a monitoring. It's been like 6 months since I did it. We built a custom Lambda extension which would run outside of the normal Lambda runtime to then push data out to an S3 bucket, which would then trigger a Lambda function, then push it out to, not Splunk, it's something else. But regardless, Lambda extensions are super powerful. So let's see what Taavi has to say on the subject. So the question is, when should you use what? That's a really good question. First things first, Lambda features can be used together. So you can use Lambda extensions and use a custom Docker image, and all that stuff is totally fine. You can also attach a Lambda layer as well. So Lambda functions with Docker. Many developers adopted Docker containers into their development environment because it helps to replicate the production environment as close as possible. AWS Lambda has a different approach to microservices. It's not based on long-running containers, but short-lived functions. It originally came with its own way of doing development, and at first people couldn't use their Docker skills. But since reInvent 2020, AWS Lambda now supports Docker images to cater to developers who are already used to a Docker-based development workflow. Instead of packaging your function code into a zip archive like normal, you can also package it into a Docker image. And it's a way to pull legacy developers from the container world to serverless. Still, it also has a crucial benefit. You get 10 gigabytes of space. So your Docker images for Lambda can be significantly larger than your zip archives. Currently, zip archives are capped at 250 megabytes of unzipped code and assets. However, if you're running this container with the Docker image, it seems like you can get up to 10 gigabytes of space, which is much more than a lot of magnitudes more than 250 megabytes. So if you have a specific use case that requires more than 250 megabytes, then this might be a way for you to kind of get around that, as Taavi's saying here, using Docker images. So one note though, your container image has to implement the Lambda runtime API. You can't run any Docker image on Lambda. It has to get Lambda events via the runtime API. Your containers won't run indefinitely like zip-based Lambda functions. They will be paused and subject to cold starts. 15 minutes is the maximum allowed time for a function. So They did increase this. I think at first it might have been or when I started, it might have been 5 minutes, and then it was like 10 minutes, and now it's 15 minutes for a Lambda function. But what Taavi's kind of getting at here is that although it has a bigger storage space of 10 gigabytes, you still have to face cold starts, and you still have a 15-minute maximum runtime, and it will still turn off when it's not being used. And then we have layers here. The most prevalent way for layers are used in custom runtimes. The most prevalent way layers are used is for custom runtimes. Okay. All right. The other way layers are used is share code between Lambda functions. So a layer is basically a way for you to take let's say you had this like big file that has to be with your Lambda code, right? And your Lambda code is your business logic for your backend API. And then you want to have 10 different Lambda functions, and then you want this big file to be attached to each one of those Lambda functions. Well, when you make a modification to your backend API code, which is going to be deployed to your Lambda function on AWS, you'll run into something where the deployment speed slows down based on the amount of stuff that you're sending to AWS, right? So if I have a Lambda function which is gigantic, let's say it's 100 megabytes, right? Then the time that it's going to take for me to say deploy from my local computer and then get to AWS is going to be much bigger based on that 100 megabytes. But if my Lambda function code is actually 10 megabytes, and then, which is still a lot, but if it's 10 megabytes, obviously node modules can get out of control, but 10 megabytes, and then I have a 90 megabyte extra file, then I can put that 90 megabyte extra file into what's called a Lambda layer, and I can separate it from my Lambda code, which is my 10 megabytes. And then as I'm making updates to my actual business logic, I'm only updating 10 megabytes at a time, which means that my local development experience is much better than using something like, than kind of packaging these both things together and then pushing it. Typically the Lambda layers, if it's not updated as frequently, then it's a good option because, if this file is only going to be updated once every month or even less than that, then we can kind of have a whole separate deployment process for that Lambda layer. It could have its own separate infrastructure as code. So we could use a separate serverless framework stack or other infrastructure as code provider stack for that. And then we'll have a separate repository even for it, or we could use a subfolder, however your team actually operates. And we can make those deployments independent of our actual backend business logic. So we can make updates to 10 different Lambda functions and then have this one Lambda layer, which we're deploying as we need to, maybe every once a week, once a month, as frequently as we need to. And then what we have to do on the Lambda function side is we have to basically point, if we need to update, we have to point that new Lambda layer version and connect it to our 10 different Lambda functions. So that process can be a little bit troublesome. Maybe it's slightly easier now than it has been in the past, but that's just one thing to point out, and that's just one example of how to actually use Lambda layers to share code between Lambda function, as Taavi's pointing out here. One caveat there to this approach of putting that extra file, that 90 megabyte file, into a separate Lambda layer and having a 10 megabyte Lambda function is that you have a sum that can only equal 250 megabytes and below, right? And so that 90 megabyte file and our 10 megabyte business logic code together is 100 megabytes. That frees up another 150 megabytes that we could use. But if we had a 250 megabyte file and a 10 megabyte of application code, business logic, then that wouldn't work. And so we still have to operate within that as well. And so he says here, if you require more than 250 megabytes or simply have a Docker-based legacy code base that would never fit into 250 megabytes, you're better off with Docker than with a big refactor. So at least in the short term. So I think, I agree with this. Like if your team is used to using Docker and you're trying to switch over to Lambda and you don't have the ability to split all these things up and get underneath that 250 megabyte limit, then what Taavi is saying here is, at least in the short term, you could use your Docker based legacy code, which you already have, and as long as it's underneath 10 gigabytes, you could use that for your deployments of your code. And then he says here, you can factor your libraries out into Docker images that become the base of all your Lambda functions instead of using Lambda layers, and won't have to fight with 5 layers per function limit here. And that's another caveat to this whole thing, is that you can only have 5 layers per function. So it has to be underneath 250 megabytes. You have 5 layers per function limit. And so, you could share. I've seen companies that will share shared code libraries. So if they have, let's say every time, you have a whole bunch of REST API code. This is a bad example. We have a whole bunch of REST API code, or let's say database libraries, and then you want to share those database libraries between a whole bunch of different teams, or let's say a whole bunch of different functions. Then you could potentially have a Lambda layer and a separate repository for that, which you make updates to, and as in a not in a frequent way. And then as you make those updates, you push it through your deployment pipeline, your CI/CD pipeline for your Lambda layer, and then you basically update the other code to then use that updated Lambda layer as you need to. And I believe that if you don't update to the latest Lambda layer, then your function should continue working using a previous version of that Lambda layer. And so it kind of can get into a situation, I guess, where if your Lambda function is not needing the most recent version of the Lambda layer that just came out, then you can still have your code be compatible and running. Then as you're ready, you can then update to the latest version. I will throw out the caveat, though, that as you get more into that and that Lambda function count grows and grows and grows and your team side grows and grows, the idea of putting your shared code into a Lambda layer and then sharing it the whole thing can get messy. And that's why you should spend time understanding, like, how are we going to approach building serverless applications? How big is our team? What is this going to look like in 6 months, 1 year, 2 years? And then really spending time thinking about, like, repository structure, how stacks are going to be built, how you're going to do organization of stacks. Is it mono repo? Is it multiple repos where some of them are mono repo? That just means that you have multiple repositories. And then, let's say you separate your infrastructure as code stacks by the ephemeral nature of it. So for instance, what I mean by that is that you might have your Lambda code, which is easily able to be replicated, right? Because your Lambda code is just, some JavaScript or some Python or some Golang. And all you have to do is deploy it from your local machine, and it'll recreate that Lambda function, and you have no data loss. But you have non-ephemeral resources, like maybe a DynamoDB table, or a relational database, or a Cognito user pool, or an S3 bucket with images and assets inside of it from users. And you may not want to have those non-ephemeral resources in the same stack as your ephemeral resources, which would be API gateway, AppSync, your Lambda functions, SQS, and so on. SQS even, I might separate that as well, because you have a queue and you can have messages in the queue, and you don't want to delete that haphazardly. And so that's where you can kind of have a single repo, which might be like the account service, and the account service might have a DynamoDB table, separate stack, S3, separate stack, Lambda functions, and API gateway, maybe that's together. Unless that API gateway has multiple Lambda functions, and then I might separate the API gateway and then have Lambda function, Lambda function, Lambda function as separate stacks. Or if they're close enough related, I might have them underneath one stack and then reuse that shared API gateway. And I might put that shared API gateway outside the account service itself and just have a shared repository of resources. And then that way it allows me to have an account service, a feed service, and a user service that all use the same shared API gateway or shared AppSync. Shared AppSync is a bit more tricky than shared API gateway, but I believe that there's work being done there to help kind of stitch the GraphQL schemas together, which is a constant problem. Okay, that's a lot of talking. So let's keep going here. So in summary, you should see Docker images mainly as a way to get more code deployed, or an easier way to port legacy container code bases to AWS Lambda. So if you're making that transition from something not immediately Lambda compatible that is coming from a Docker container background, then that's where this idea of using Docker images to deploy your functions as a more attractive option. My go-to initially would always be to not go the Docker route unless you have to. And I would say, stick to writing your JavaScript and then deploying it onto the Lambda container that's provided by AWS automatically in the background, just because it's less work and less moving pieces, less things to mess up, automatically updates in the background. And it just makes CI/CD pipelines easier and a whole bunch of other things easier as well. But if you can't do that, or if you need to make progress quickly and you need to move things over so that you can start adding to it, then this is a valid option as well. Also, as it says here, if the 250 megabyte limit doesn't work for you, so if that zip limit doesn't work, then you can use the Docker image route just to have more storage up to 10 gigabytes. Lambda layers are a way to add libraries, frameworks, util folders, and custom runtimes to your Lambda function. So I've seen that previous to some of the runtime support, AWS Lambda has a lot now, but previous to that, people make custom runtimes for, I believe even PHP and Rust and a few other things as well. And so now they're getting a little bit more formal runtime support from AWS Lambda. But in the past, people used this kind of custom runtime Docker image, or Docker Lambda layer type of approach to basically get past that. Lambda extensions are Lambda layers that can run in a separate process. So they can run, I believe, during shutdown, and then one more, but I can't think of it off the top of my head. There's a lot of deep dives into Lambda extensions. I believe Serverless Guru might have even wrote a article about it. We did a lot of work in the past with Lambda extensions when it first came out, and I personally helped build some stuff around it. So what that does is that it runs in a separate process, and then it allows you to send things from the Lambda function out, and it can be like, let's say at shutdown, so your Lambda function runs, it stores some data, and at the very end, it then sends that data to something else. And then from there, it then sends it somewhere else. That can help because in some ways in the past, like we would have to wrap our Lambda code with a third-party provider. So I would write my handler function for my Lambda function, but then I'd have to wrap it with some third-party provider. And that was kind of messy because, it added dependencies. It made the code a little bit weirder because this third-party provider was kind of wrapping over my code, which just felt kind of weird. And now there's different ways to go about it, like this Lambda extensions way, where you can kind of get around adding stuff to your specific code, but then have this Lambda extension that will add to the Lambda function to then send that data to the third-party provider, outside of the normal code running process. And it says use cases here are monitoring or secret gathering. So thanks Taavi from Dashbird for pointing this out. If you haven't heard Taavi and I talk on the Serverless podcast, you can go here to the serverlessguru.com website and then go to the podcast section. We've got a website here called talkingserverless.io, and you can find us on iTunes, Google Podcasts, and a few more things. And I believe we search here for Taavi. Let me search. Here we go. So Taavi, and then we have the CEO of Dashbird, and you can listen to this episode, and it was episode number 28. I think there's even, let me see, latest episodes. Yep. And if you go to the episodes list here, you might be able to find the transcription as well, if that's interesting. So if we click here, you can see the transcription, and you can kind of listen to the audio clip as well as reading through some of the questions that were asked. Hopefully that's useful. And I think on that note, I'll probably wrap up this live stream. Let me double check if there's any chat. Looks like there's not. I appreciate y'all for watching, and I'll see you next time on Coffee with Ryan.